Okay, let's begin the systems assessment review. Question 1. Rebecca works at a music store. Last week she sold 6 more than 3 times the number of CDs that she sold this week. Rebecca sold a total of 108 CDs over 2 weeks. Write a system of equations that can be used to find L, the number of CDs she sold last week, and T, the number of CDs she sold this week. So the variables we're going to use are L for last week's CDs and T for this week's CDs. So let's begin by looking at the second sentence. Last week, that's L, she sold 6 more than 3 times the number of CDs that she sold this week. That's T. So L equals to 6 more than, that's plus, 3 times the number of CDs she sold this week. So 3 times T plus 6 more. The next sentence says Rebecca sold a total of 108 CDs. So that means last week we don't know how many CDs she sold, plus this week we don't know how many she sold, but we know she sold a total, so it's going to equal to 108 CDs. And that's all you need to do is just write the system. You don't have to solve it. Question 2. Sheila has 75 boxes at home. Some of these boxes weigh 25 pounds. The rest of the boxes weigh 12 pounds. All of the boxes weigh a total of 1,576 pounds. Write a system of equations that can be used to find X, the number of 25-pound boxes, and Y, the number of 12-pound boxes Sheila has at home. So our variables this time are X for 25-pound boxes and Y are 12-pound boxes. Well, how many boxes does she have at home? She has a total of 75 boxes. We don't know how many of those boxes are 75 pounds or 25 pounds, X, and we don't know how many of them are 12 pounds. So we have to add X plus Y equals a total of 75 boxes. Now we know how much each of them weigh. Some of them weigh 25 pounds, so 25 times X. We also know that the rest of them weigh 12 pounds, plus 12 times Y, for a total of 1,576 pounds. And that's it. That's our system of equations. You do not need to solve it. Question 3. Graph the system of equations below, and what are the solutions to the systems? So let's take the first equation. We have 2x plus y equals to -4. We need to solve for y. We need to write it in slope-intercept form. So we need to get rid of 2x. So we're going to subtract 2x from both sides. So we get y is equal to -2x minus 4. Now we got to graph this on our coordinate plane. Now I'm going to apologize for the graph. You can't see the lines very well. You're going to have to estimate where they're at. So our y-intercept here is at -4. So you're going to go down to -1, 2, 3, 4 on your y-axis. And then your slope is -2. So when we write our slope as a fraction, that means we're going to go down 2 and right 1. So let's go down 2 units from that point and right 1. Do it again, down 2, right 1. Do it again, down 2, right 1. You can also go up 2, left 1, up 2, left 1. And that's a good enough number of points. And then go ahead and draw your line. I do not have a ruler with me, so I'm going to use the edge of my calculator. So there's our first equation. Now we're going to graph the second equation, 2x plus 3y equals to -12. So let's type in 2x, or right, 2x plus 3y equals to -12. And now we need to solve for y. Subtract 2x from both sides. We end up with 3y is equal to -2x minus 12. Divide everything by 3. We get y is equal to -2/3 x minus 12 divided by 3, 4. So here's our equation. So our y-intercept is at -4, and our slope is -2/3. That means we're going to go down 2 and right 3. Down 2 units and right 1, 2, 3. Down 2, right 1, 2, 3. And then you can already see where your intersection is. It's actually the y-intercept on this problem. Go ahead and draw our line. And the point of intersection is where the two lines, that's the solution. The intersection is the solution to the system. So the solution to the system is located at 0, -4. Now I'm going to show you how to check your answer on the calculator. All answers on your test can be verified and double-checked on your calculator to see if you got it right. So we're going to go to 1UDocs. I'm going to delete whatever's there, and we're going to go to 2AddGraphs. Now I want us to write our equation into our calculator. Now let's say I'm not too sure that I converted it correctly. So you can actually type in the equation the way it looks, but you have to erase the f of x. So you have to push the delete key and go down to number 6 where it says relation. And then you can go ahead and type in the original equation you see right here. 2x plus y equals to -4. Push enter, there's your line. Now I need to put the second equation on there, so I'm going to push tab. Now I'm going to type in the equation the way it looks. 2x plus 3y equals to -12. Enter. There's your system. Matches our graph. You can find where they intersect by selecting Menu, 6, Analyze Graph, and 4, Intersection. You're going to move that line to the left and push enter, and then scroll it over to the right, push enter, and there is your point of intersection. It is located at 0, -4. There's our answer. All right, the next problem. Let's go ahead and find the solution to the system. So let's start with the first equation. So we're going to take -3x plus y equals to 2. I need to solve for y. So let's get rid of 3x. We're going to add 3x to both sides. So we end up with y equals to 3x plus 2. Now we got to graph it. The y-intercept is 2. Our slope is 3. That means we need to go up 3 and right 1. Up 3 units, right 1. Up 3 units, right. So here we go. 1, 2, 3, right 1. It's a little off because I can't see my lines. All right, so let's go ahead and graph that, draw our line. Now we're going to graph the second equation. Again, we can't graph it until we convert it into slope-intercept form. So 6x minus 2y equals to 2. We're going to subtract 6x from both sides first. So we end up with -2y equals to -6x plus 2. Divide everything by -2. Y equals to -6 divided by -2 is 3x. 2 divided by -2 is -1. So there's our equation. What do you notice about both equations? The y-intercepts are different, so this one's down here at -1, but the slopes are exactly the same. So if you graph the same slope, what are the two lines going to be? The two lines will be parallel to each other. If the two lines are parallel to each other, that means what's the solution to the system? There is none. The answer is no solution. There's no solution to the system of equations. Again, you can verify on your calculator by graphing both equations on here, and you can verify that it's going to be parallel. Number 4, a jewelry company is investigating 2 plans for selling necklaces. Each plan can be represented with a system of equations. One line represents the expenses of making the necklaces. The other line represents the revenue from selling necklaces. The graphs of the 2 plans are shown below. So there's our graph of the expenses, and then the other one for the revenue. What is the solution to this system of linear equations? What does the solution represent for the plan? So we need to find where the 2 lines intersect. In order to find where the 2 lines intersect, we need to go ahead and find the slope of both lines and continue graphing the slope. So I'm going to make this graph a little bigger so we can figure out where they are. So here's one point right here at 0, 200, and now we need to find another point of intersection on the line. And here it is right here at 20 and 225. So that means we need to go up 1 unit and write 1, 2, 3, 4 units. So we're going to do the same thing. Go up 1 and write 1, 2, 3, 4. oops, 4 is right here. 1, 2, 3, 4. There it is. And go up 1 over 1, 2, 3, 4. And then you're going to extend the line through those 2 points. Now we need to find the slope of the revenue line. Well, the origin is one of the points. The other point, you have to look and see where is it exactly located on here, and you will find it right here at 20 and 125. So it's up 1, 2, 3, 4, 5, and over 1, 2, 3, 4. So we're going to do that again. 1, 2, 3, 4, 5, and over 1, 2, 3, 4. There it is. So then extend your line out right there. And here is the solution to the system. It's located at 40 and at 250. So the solution is 40, 250. And what does this represent for the plan? 40 represents the number of necklaces sold. The 250 represents the dollars, where expenses and revenues are going to cost the same. So you're going to write down 40 necklaces sold for $250. This is when expenses and revenue are the same. Number 5, a candy company sells cases of chocolate bars. The company has fixed cost of $30,000, and each case of chocolate bars cost an additional $5 to make. The company sells each case for $10. The graph of a system of linear equations represents this company's cost, and the revenue for manufacturing and selling X cases of chocolate bars is shown below. The question is, how many cases of chocolate bars will this company need to sell in order for the cost of the revenue to be equal? So we need to find where they intersect. Well, it's off our graph, so we can't figure out where they intersect on the graph, but you have the 2 equations on here. Here's one equation and here's a second equation. So we have a solution, system of equations. So we need to find the solution. Since they're both written in slope-intercept form, we can go ahead and graph it. However, the graph, you won't be able to see it because it's at 30,000, so you're going to have to fix your window, and I haven't taught you how to do that yet. So you're going to go ahead and either use substitution method or elimination method. Since both of these are solved for the variable y, we're going to go ahead and use the substitution method. So let's write down our 2 equations. Y equals to 30,000 plus 5x. The second equation, y equals to 10x. To solve the system of equations by substitution, you have y is all by itself, so we're going to take 10x and substitute it in for y in the first equation. So now we're going to write our new equation. 10x equals to 30,000 plus 5x. And now you just solve the equation from there. So we're going to subtract 5x from both sides. 10x minus 5x is 5x, and then we still have 30,000, and then divide both sides by 5. 30,000 divided by 5, put that in your calculator, what do you get? You get 6,000. X represents your x-axis, which is the number of cases in the thousands. So how many cases were sold? We have our answer right here. So the question is, how many cases of chocolate bars were sold? Well, 6,000 cases were sold for when the cost and the revenue are going to be equal. So that's all you have to do. That's your answer. Now I'm going to show you a trick on the calculator that will help you solve systems of equations. So let's go ahead and go to OneUdoc. Except this time we're going to open a calculator page. So we're going to go to 1. So we're going to select menu and then go down to 3 for algebra. And then there's actually a spot here that says solve systems of linear equations. And that's what we want it to do. So we're going to push enter. We have two equations we wanted to solve. We're going to use the variables x and y, so we're going to select OK. So now on the top part, we're going to write our first equation that we got. So it's y equals to 30,000 plus 5x. And then the second one, y equals to 10x. Push enter. There's your solution. The x is the first number, the y is the second number. All we need to find is the value of x, which is 6,000, and that's what we got for our answer. So it's correct. Question 6. There are 156 laptops and desktop computers in a lab. There are 8 more laptops than desktop computers. What is the total number of laptops in the lab? Write a system of equations and solve the system to find the number of laptops. That's all we need to find, laptops. Before we do anything, we have to write a system to represent this. So we need to identify our two variables. So we're going to use x for laptops and y for desktops. So x represents the number of laptops and y the number of desktops. So how many computers are in the lab altogether? A total of 156. So we get x plus y equals to 156. There are 8 more laptops than desktop computers. So that means there's more. We're going to add. We have to add to the desktops to find out how many laptops are in there, because there's 8 more. There are more laptops. So that means x is equal to y represents desktops plus 8, because laptops is equal to 8 plus however many desktops are in there, because there's more laptops. Now, how are we going to solve the system? Are we going to use substitution method or elimination method? I would use substitution method here since x is all by itself. So we're going to take y plus 8 and substitute it in for x in the first equation. So we get y plus 8, and then we write the rest of the equation, plus y equals to 156. And then you solve the equation from there. Y plus y, there's 2 y's, plus 8 equals to 156. Subtract 8 from both sides, and we get 2y equals to, what's 156 minus 8? You will get 148, and then divide both sides by 2. What's 148 divided by 2? You get 74. So y represents the number of desktops. There's 74 desktops in the computer lab, but the question is asking us how many laptops are in the lab. So we have to go back and plug in 74 in for y in the second equation. So we get x equals to 74 plus 8. There's 8 more in there. So what's 74 plus 8? Work that out. You get 74 plus 8 is 82. This represents your x's, which is laptops. 74 is your desktops. 82 is your laptops. The question is, find the number of laptops. There are 82 laptops in the lab. Number 7, at a firefighter's pancake breakfast, the firefighters served 345 people and raised $1,395. If the cost of A, an adult's ticket to the pancake breakfast, was $5, and the cost C, a child's ticket, was $3, what was the number of adult tickets sold? Write a system of equations and solve the system to find the number of adult tickets sold. So we know how many adult tickets were sold, but we need to write a system of equations to help us figure that out. So what do we know about how many people were served at this breakfast? There were a total of 345 people were served. So we're going to do adult plus child for a total of 345 people. Now the second equation is going to be about how much money was raised. Well, an adult ticket cost $5, so we're going to write 5A, and a child ticket is $3, so you're going to write 3C, for a total of $1,395. So since they're both in standard form, we're going to go ahead and use elimination method to solve it. I want to get rid of my C variable, so I need to get the opposite of 3. So I need to multiply the first equation by -3. So then we're going to get -3 times A, which is -3A, -3 times C, -3C, and -3 times 345. and then you get negative 1,035. And now we're going to solve the system. Let's go ahead and cancel out the C's. Combine 5a minus 3a, we get 2a. 1,395 minus 1,035 is 360. Divide both sides by 2. We get a equals to 180. Now the question is only asking us for adult tickets, so that's all you need to find. There were 180 adult tickets sold. Question 8. What is the solution to this system of equations? Use substitution method or elimination method to solve the system. You must show your work. So we have two equations written here. What method should we use? Well, one of them has the variable all by itself, so I'm going to use the substitution method. So we're going to need to substitute in this equation right here in for y into the first equation. However, I'm going to go ahead and simplify this equation before I begin my substitution method. What's negative 13 divided by 2? We get negative 6.5x. What's 92 divided by 2? We get 46. So then we're going to go ahead and substitute this in for y into the first equation. So we get 10x minus, I'm going to put this in parentheses, negative 6.5x plus 46 minus, or equals to, 53. Now you have to solve that equation. Since we have a minus sign in front of that y, so we have a double negative here, so that means we need to distribute the negative sign before we can combine our like terms. So 10x plus 6.5x and negative times a positive 46 will give us a negative 46 here. And then we're going to go ahead and combine like terms. 10x's plus 6.5x, we get 16.5x minus 46 equals to 53. Add 46 to both sides of the equation, and we get 16.5x equals to 53 plus 46 will give us 99. Divide both sides by 16.5, and we get x equals to, put this in your calculator, what's 99 divided by 16.5? You get 6. So x equals 6. Now you're going to go back and substitute in 6 for x in one of the equations. Doesn't matter which one you pick. I'm going to go ahead and pick that bottom equation. So y equals to negative 6.5 times 6 plus 46. So let's solve that. Negative 6.5 times 6 will give us negative 39. And now we have to add 46 to negative 39, and y equals to 7. So we get x equals to 6, and y is 7. So here's your solution to the system. Again, you can always check your work using your calculator to verify. So menu, algebra 3 and 2 solve systems of equations. So you're going to select OK. And then the first equation, we're going to type in 10x minus y equals to 53. Go down to the second one, and now we're going to type in the second equation, and we get y equals to, and I have a fraction here, so I'm going to go and do to control divide, and type in negative 13x plus 92 over 2. Enter. There's your solution. That's what we got. Okay, number 9. What is the value of x in the solution to the system of equations? All we have to find is just the x value. So I'm going to go ahead and use substitution method. So I'm going to take this negative 6x plus 18 and substitute in for y into the first equation. So we get 3x equals to 2 times, instead of y, we're going to write negative 6x plus 18 and then plus 14. Now we're going to solve the equation. To solve the equation, we're going to do distribution first. So we get 3x equals to 2 times negative 6, negative 12x. 2 times 18 will be 36. And then bring down plus 14. Now we're going to combine like terms. What is 36 plus 14? So we get 3x equals to negative 12x plus 36 plus 14 is 50. Now move the variable over to the left side of the equation. So we're going to add 12x. So what's 3x plus 12x is? We get 15x and equals to 50. And now divide both sides by 15. You get x equals 2 10/3. You can leave your answer in that form. You did not need to solve it. That is our answer to the problem. Because all it's asking us is to find what's the value of x. Again, you can check it. Menu, algebra, 2. We have two equations. We're going to use the variables x and y. So we say OK. Type in the first equation in here. 3x equals 2y plus 14. Go down to the second one. Y equals 6x plus 18. Enter. There's your solution. You only want the x value, so the x value is 10/3. So we got it right. All right, number 10, graph the inequalities below. Before you graph it, I want you to go ahead and write down these notes on your paper. Greater than or equal to, solid line and you shade above. Less than or equal to, solid line, shade below. Greater than, a dashed line, shade above. And less than, a dashed line and shade below. All right, so let's go ahead and graph our inequality. It's already in slope-intercept form, so we don't need to convert anything. So we're going to plot our y-intercept of -2. Now we have to plot our slope of -7 halves. So we're going to go down 7 and right 2 from this point. 1, 2, 3, 4, 5, 6, 7, and right 1, 2. I'm going to go up 1, 2, 3, 4, 5, 6, 7, and left 2. And then you get your ruler, and we're going to draw a solid line since it's also equal to. So I don't need to make it dashed. And then it's greater than, so that means we're going to shade above the line. Now, which of these ordered pairs is in the solution set? So let's plot 0, -2. Here's 0, -2. It's on the line, so yes, it's in the solution. What about 2, 3? So here's 2, up 1, 2, 3. It's in the shaded region, so yes, it's in the solution. -1, 3, and -1, go up 1, 2, 3. There it is. It's in the shaded region. Yes, it's in the solution. 0, -5. Here's 0 down to -1, 2, 3, 4, 5. It's not in the shaded region or on the line, so no, it's not part of the solution set. -2, 1. Go to the left, -2, up 1. It's not in the shaded region. It's not in the solution set. And the last one, -4, 5. Here's -4, up to +5. It is not in the shaded region, so no, it's not part of the solution. Again, you can check it. Check your graph to see if it matches your equation, your inequality here, by going to add graphs. But you need to delete the equal sign, so you push delete, and you're going to select y is greater than or equal to 5, and then type in -7 over 2 x minus 2 and enter, and then there's your graph. It matches, so that's the answer. Okay, the next one on the right, we have -2x plus 3y is greater than 12. We have to convert that into slope-intercept form, so we have to solve for y before we can graph it. So I wrote it up here. Let's go ahead and solve for y. We need to add 2x to both sides of the equation first, or inequality first. So we get 3y is greater than 2x plus 12, and then divide everything by 3. So we get y is greater than 2/3 x plus 4. So there is our inequality. So let's graph 4 on our y-axis, and then up 2 over 3, since it is positive. So up 1, 2 units, and over 1, 2, 3. Up 2 units, over 1, 2, 3. Try to see where that's at. Okay, do the same thing on the next one. Let's go down 2 units and left 1, 2, 3. Down 2 units. Oops, down 1, 2. And then over to the left 1, 2, 3. There we go. So it's greater than. There's no equal to. That means we're going to draw a dashed lines in between. And then it's greater than, so that means we're going to shade above. All right, which of the ordered pairs is in the solution set below? So let's test it out. -3, 2. Let's go -3, up 2. It's on the dashed line, so that means it's not part of the solution. What about 2, 6? 2, 6 is up here. It's in the shaded region, so yes, it's part of the solution. -3, 3. -3, 3 up here. It's in the shaded region, so yes. What about -2? -3, it's way down here, so no, it's not in this solution. And then what about 2, 3? 2, 1, 2, 3. Nope, it's not in the solution. And 0, 4 is on the dashed line, so no, it's not part of the solution set. All right. Again, you could put this equation inequality in your calculator and you could check your graph to make sure it matches it. Number 11, solve the system of linear inequalities by graphing. So we're going to go and take the first inequality and we need to solve for y. So I'm going to write 4x plus 3y is greater than -12. So we need to move over the 4x to the other side, so we're going to subtract 4x from both sides of the inequality. So we end up with 3y is greater than -4x minus 12. Now we have to divide everything by 3. So then we get y is greater than -4/3 x minus 12 divided by 3, 4. So there's our first inequality. Let's graph it. -4 on the y-axis. Slope is -4/3, so we go down -1, 2, 3, 4 over 1, 2, 3. And then we can go also up 4 and left 1, 2, 3. Okay, since it's greater than, that means it's going to be a dashed line. So you get your ruler and you're going to draw a dashed line through the points. And since it is greater than, that means we have to shade above. Okay, the second inequality is -3x minus 10 is less than or equal to -2y. Now this one's a little tricky. We're used to seeing the y on the left side of the inequality. So what I'm going to do is I'm going to take this inequality and I'm going to flip it. I'm going to rewrite it so that the y is on the left and the -3x minus 10 is on the right. But now look at this inequality. It's open to the -2y. So let's go ahead and write -2y, and it has to be open to it. So that means we have to write our inequality like this. And then now write down -3x minus 10. Now we need to solve for y. So we're going to divide everything by -2. So now we get y. Since we're divided by a negative number, the sign flips again, so it's going to be less than or equal to. And then -3 over 2 is 3 over +3 over 2, and -10 over 2 is +5. So now here's our inequality that we need to graph. So let's plot 1, 2, 3, 4, 5 on the y-axis. The slope is 3 over 2, so that means we're going to go up 3 and right 2. 1, 2, 3 over 2. And go down 3 and go to the left 2. Since it's less than or equal to, that means we're going to draw a solid line. And then it's less than, so that means we're going to shade below. Now, the region where both graphs overlap, anything in this section here is a solution to the systems of inequalities. It has to be located in this shaded region where they both overlap, anywhere on this solid line, but it can't be any point on this dashed line because that's not part of the solution set. So now we're going to test out these ordered pairs and see which ones are in the solution set. Is 0, 5 a solution in the solution set to the system of linear inequalities? Here's 0 down to -5. Nope, it's only in the red shaded region. It's not part of the solutions. Oh, I did 0, -5 instead of +5. So 0, +5 is up here. It's on the solid line, and it's also next to the shaded region. So yes, it is part of the solution. What about -5, 0? -5, 0 is located over here. It is not in the solution set. 2, 1, it's in the shaded overlapping region. So yes. -3, -2. -3, -2 is down here. It's only in one region, not the other, so it's not in the solution set. Negative 3, positive 2 is located over there in the orange region, but not in the red region, so it's not part of the solution set. And 0, negative 4 is on the dash line. It's only part of the solution for the red one, but not the orange one, so it is not in the solution set. Only those two are. Okay, bring your review tomorrow when you take your test, and you may use the review on the test that you will take tomorrow. And another thing is you can also double check your graphs by graphing it on your calculator. Let's just double check that real quick. So to add graphs, and we get rid of that, so we're going to push delete. And we need to type in this inequality exactly the way it looks. So you're going to go down to 6 relation, and you're going to type it in. 4x plus 3y is greater than, and then negative 12. Enter. There's your first graph. That's the one that matches right here. It worked so far. And then now we're going to do tab and type in the second equation. Negative 3x minus 10, or inequality, sorry. And control equal to, we're going to go less than or equal to, and negative 2y. Enter. There's the other one. So there's your overlapping region right here. We graphed them correctly. All right, study, be ready for your test tomorrow.